Malware, basically a program intentionally designed either to steal information or to disrupt computing. Malware evolves time to time and creates challenges to the computing world. Researchers are also looking for solutions so that malwares can be detected at their first occurring. Hi, I am Dr. Vinayak Panda along with my friends Dr. Sudham Sekhar Bisoy, Mr. Siddhant Manigrahi, and Dr. Prithviraj Mohanty, showcasing our research work on a multi-class malware classification problem. Malcoders normally makes use of several techniques to evade the detection. API obfuscation is one of the such technique where they introduce dummy APIs or repeat APIs so that the detection will not be possible. Now, this was the real challenge where we need to think of removing these obfuscated API calls, getting back such API sequence which can really classify the malware or which can really speak about the behavior of the malware. During our research, we have considered the collected API sequences of several malwares to classify them. Conventionally, malwares are classified against benign programs, but looking into the diversity into malware classes, classifying malwares against other malwares is also one of the research area. We have considered the multi-class malware classification as the problem statement. During the work, we thought of exploring the semantic relationship among APIs in the API sequences, and we are investigating the hypothesis whether the API semantics can classify the malware as per their classes effectively or not. A careful observation on API sequences reveals that specific APIs are getting repeated. This makes the API sequences quite lengthy, and this can be referred as a horizontally unbalanced API sequence. Now, during our work, we have addressed this problem. We have suggested a methodology named as adaptive feature selection, which reduces the API sequence length and makes it useful to explore the semantic relationship between APIs, which can contribute towards classifying malwares.
We got surprising result. We found that selecting significant APIs from an API sequences and their propositional semantic ensure a better classification ability than others.
We came across two important challenges during our work. The first one is about dealing with the horizontally imbalanced API sequences due to presence of obfuscated API calls. Second one, ensuring a termination of the greedy approach based adaptive feature selection technique.
Those who want to do research in computer security and cyber security, more specifically in malware analysis, will find this article very interesting. This work proposes a adaptive feature selection technique which removes obfuscated API in an API sequence, making the API sequence more suitable for further analysis. The study resulted in the rejection of null hypothesis, which I talked about as the alternative hypothesis. The positional correlation between API in API sequences has a significant role in multi-class malware classification. We have observed a few limitations in our research that may be extended further in the future. Number one is improving the greedy choice property in adaptive feature selection. AFS may further enhance the classification matrix. Number two, the proposed iterative feature selection technique, which is adaptive feature selector, may be compared with the recursive feature selection technique to ensure its efficacy. On a global scale, this contributes to cyber security by detecting known and unknown malware families while analyzing their attack pattern through API sequences. We expect our paper to have a bigger impact on this area.